Library of functions. We're going to be looking at what I call the basic functions. These are the plain vanilla functions. They're plain vanilla. You should be able to recognize them, draw them. If I say draw the basic cubic function, you should be able to do it. If I said basic quadratic, should be able to do it. Your book describes the line in 3 pieces. I personally will always deal with y equals mx plus b, but they deal with it in 3 pieces, so I have to deal with it in 3 pieces. The linear function is of the form y equals ax plus b. The domain, if you notice these have arrows on the end, is all real numbers, and what's the range? Yep, all real numbers. No denominator, no radical, all real numbers. Now they call this thing the constant function. It's of the form y equals b, where b is a real number, a constant. And the domain, no radical, no denominator, is all real numbers. And what about the range? Y equals what? Not 1. Well, in this case, because it's got a, you say y equal 1. But in general, it would be y equal whatever this is, right? In this case, it would have been y equal 1 if each hashtag hash was 1 unit. The third one they call the identity function, and that's y equals x. To me, they're all straight lines, so y equals x, and his domain is, and his range is, okay, let's leave that sucker. The big ones are going to be x squared, x cubed, square root of x, absolute value of x. Those are the big guys. And that's, we start here. This is y equals x squared. What's his domain? All real numbers, but what's his range? No. Yeah, he starts at what? 0 and goes forever. His range includes 0 to infinity. Now we've just dealt with x cubed. Y equals x cubed. He's an S curve. Kind of S-y like. Or snaky. What's his domain? All real numbers. What's his range? All real numbers. Boring. And I'll put all these on one video. Reciprocal function. We won't deal much with him until chapter 3. What he actually looks like, if you want to draw him, it's kind of hard to see. That's what he really looks like. What's his domain? Negative infinity to 0. Another way of writing this, of course, is all real numbers, x can't be 0. Either way. Depends upon what we're doing with it is how we're going to write it, actually. Absolute value function, he's a v. What's the domain? What's the domain? Negative infinity to infinity, all real numbers. What's the range? 0 to infinity, yeah. Including 0 to infinity. And square root function. 0 to infinity, including. What about the range? Same thing. See, he continues to go up and up. So he also goes, the range also 0 to infinity. Those are the big guns. The big guns are going to be x squared, x cubed, absolute value of x, square root of x. Those are the big fun. Those are going to be the big functions in 1.5. Now this I'll introduce to you. We don't use him. If you're going to take the engineering calculus, he's used as a bunch of what we call counter examples. So in other words, if you're looking for something of which you're working with, you can't do it with, you'll say, oh, greatest integer function is an example of something you can't do that thing on. It's called a counter example. And it's called the greatest integer function. If you are going to take computer programming at all, you'll run into it there. Another way of writing this guy, and our calculator writes him, is going to be int of x. That's how the calculator does it. Most computers, if you're writing a program, int of x is what it uses, called the greatest integer function. Now, what does the greatest integer function do? Well, first of all, I know what his domain is. He has no radical. He has no denominator. So what's his domain have to be? All real numbers. The range is the guy who's tricky. Now, what the greatest integer function does is this. That int of x rounds down to the nearest integer. Now the integers being -2, -1, 0, 1, 2, so on. So that's dots in both directions. Rounds down to the nearest integer. So int of 0.5 is the same as what?
1.
Rounds down with 0. Now, by the way, if you're on the plus side of things, it's easy. Remember, the book often writes 0.5 as 0.5. If you're on the plus side, you just cut off the decimal. So it's easy. So that int of 1.2 would be 1. So you just kill the decimal. So that's easy. Int of 1 would be 1, yeah. So if I think about what this guy is going to look like on the positive side, int of 0 would be 0. Because I'm just cutting off the decimal. Any place between 0 and 1 is going to be int of 1/2 is, or 0.5 is 0. Int of 0.9 is 0. Because remember, it's truncating the decimal. It rounds down to the nearest integer. And so it stays 0 until you get to 1. And there's an open hole here. Int of 1.5 is, int of 1.9 is, int of 2 is 2. So that says it's 1 till it gets to 2, then it jumps. Between 2 and 3, it is 2 till it gets to 3, then it jumps. Between 3 and 4, it's 3 till it gets to 4, then it jumps. And it keeps on going. He is weird, is he not? Really weird. Now, if I'm going the other direction, 0, and guess what? It continues to go down. What does it look like? Stair steps. And it really is called a step function. And essentially, he does pass the vertical line test, so he is a function. But he is just weird. When I used to teach computer programming in BASIC, we used him to do a change machine. One of the programs they had to write was a change machine. You know, where you go into the movie theater or what have you, and then they give you the dollars back, and then the change comes out in a little tray. A change machine. And that was used to write that particular program. Now, what's the range? No, it's not all real numbers. What's the only thing that y can be? It could be what? 1, 2, 3, 4, 5, 6, 7, 8. What are those called? Whole numbers. And if I go backwards, -1, -2, -3. They're all integers, yeah. So what's the range? Well, the range is ... -2, -1, 0, 1, 2, ... Or we could say the integers. He's weird. Good news is we don't run into him much here.